Good evening, Dr. Barth.
Hey Eric, how's it going?
Good. Welcome to Rubber Duck Engineering. Tonight, we are going to continue our grand quest upon integrating our newly made garbage collector into SafeRen, which is a Wren interpreter that we wrote. If you follow this show, we wrote some months ago.
This is going to be an epic playlist when it's finally all assembled.
Oh my goodness, yes.
So Eric, I heard that you actually got it running. You put the garbage collector and the VM together and it didn't crash, or it crashed a little bit and doesn't crash anymore?
I was blocked for a while. There's like a phase of like a design phase when you like have to sort out the design issues, and you and I had to have some time to do that. But anyways, we finally got some time this weekend, and I got unblocked, and I went crazy. Hello, actually, yes, got them integrated last night and the night before.
That's awesome. I remember you were fighting with the compiler errors on your integration branch for quite a while.
Yeah, and I haven't landed in the main branch yet, because what I want to do is I want to look at the sort of the final integration and compare it to what the main branch looked like, both in terms of like what tests pass or not, because it should be identical, but also just to judge aesthetics, like, because it's really hard when you build up one of these to see how far off into the weeds you ended up with from an aesthetics point of view. So, but that'll be fun.
I think today we want to focus on benchmarks, right? We got it running, and you said you ran the benchmark. Should we take a look at how amazingly fast everything is?
Yes, how amazingly fast everything is. Yeah, I think it'd be fun to actually play with it, because it is to a point now where we can benchmark it, and there's like a whole class of issues that we just never tackled in the garbage collector because we weren't like forced to. Like, I don't think we've taught the thing how to collect yet, or we taught it how to collect, but we're never collecting.
Yeah, I don't think we ever actually collect, and also I don't think we ever free any global variables. If you ever declare a global, it'll just be there forever.
Yeah, so it is definitely not production ready, but it's ready enough to poke at least. So, shall I load up the code machine?
Yeah, to the code machine.
So let's see. This is, instead of the vmgc, which is what we've been staring at, this is back to the SafeRen code base, where it still says the old title Ren Rust because I haven't renamed my checkout. But yeah, I can show you that it works. It has a bunch of warnings because our integration isn't fully done. I had to comment out like the C API. But like, here is a benchmark that we can stare at. This is the string release benchmark. As I said, it splats out a whole bunch of warnings, which we can all ignore for now, and then it runs it.
Amazing.
Yeah, like I mean, 2 days ago it was barely adding integers, and then I spent a while converting this code. What was it in core? This is like all the implementations of like.
So this is the string equals benchmark. Do you want to show us the string equals function so we get a sense for what these things look like?
I actually don't know what the string equals benchmark does. It just happened to be the one that I happen to have loaded up in the profiler from the last time we were looking at this.
Oh, I kind of assumed it would see how fast string equals goes.
This is the string equals benchmark.
Okay.
So what is that, 1 million? Something like that. 1 million times. We
check some strings and add some numbers. Seems like a really good like micro benchmark to look at.
Great. Anyways, so that's that. If we look at core, we should see string. I don't know if it's going to be string equals. It's probably actually object equals. Object equal. Probably this. This is probably the code that it goes through, where we needlessly create a bool in our scope.
Yeah, I think so. So in the GC, we have all these fancy tag pointers and heap handles and stuff. But like when you did the conversion, you did it in the most naive way possible, just to make sure it would be correct. And so I think it's not surprising that it's pretty slow, but I think it's still a good exercise to see which of these performance optimizations matter, as opposed to prematurely optimizing, making assumptions.
Yep. And so I can flip over to a profile that I took right before in my other Easy Bake Oven. That'll take just a second. So I have to stop presenting. Since we were last doing this, I changed how I did my.
So I can tell you my theory, or what I think is going to happen.
Sure.
Is the way you have object EQ set up, you're allocating a local handle to return. Correct. I suspect if we change it to be an out parameter that is a heap handle, which doesn't involve any allocation, that's going to be the thing that makes it go fast. But let's find out.
That is likely related. So I don't remember how to use this tool because it's been months. It's not that I don't know how to use a profiler. I don't remember the specifics of this specific one. But it looks like the top thing is run frame in fiber, which is that's like high level ops instruction. So this makes sense. You would spend all your time there. I don't remember which exclusive and inclusive is. I think inclusive is time under this, and exclusive is like specific to this function.
Mm-hmm. Like I noticed that handle scope add, for example, is the third symbol.
Yeah, so this is super concerning. Like this should not be here.
Oh, is the thing on the right, is that the callers? Oh, call stacks was the callers.
I believe these are the call stacks. We could stare at this a little bit more. I remember I was looking for a tool like this on Windows because I'm familiar with tools like this on Linux, and I'm familiar with tools like this on Mac, some of which work from the command line, and I just couldn't find a good one on Windows. So I found this like little freebie one that seemed to work kind of like I was expecting. So anyway, so this one, handle scope add, it looks like 27% of calls are this create num.
And then can we draw into that? Like who's calling create num? Num plus and range iterate.
Oh. Let's see. Oh, you can't see that other. Okay, sure. Range iterate.
Can we look at range iterate in the code?
Yes. let me wave my magical wand and switch windows here. I may need to work on my setup.
So this must be the loop. When we're in the benchmark, there was a big loop at the top that went up to 1 million.
All right, so this is in range iterate.
Okay, start the iterator. I don't imagine it's that one.
What did we call this? What did we say this was?
Create num was the thing we were calling.
Oh, create num. Like this one? Start the iteration, okay. Oh, it's this one, I bet. Validate num.
No, this isn't called create num.
I thought this returned. No, it doesn't. Okay. I thought that returned.
The bottom, like that one.
Yeah.
Mm-hmm. So I think these kinds of changes.
Good, sorry.
Okay. I was going to say, this is another example of a function that returns a local handle. And so we can avoid actually creating the local handle by changing this to have a heap handle out parameter.
I mean, these aren't the hot paths, but this is absolutely banana pants, right?
Yeah.
How much work is being done to create the one shared false bool?
Right. I mean, sort of the point of having these tag pointers is that you can deal with numbers and Booleans and such without allocating any object because you encode them directly in the pointer. And we're just not taking advantage of that.
Well, we are doing that, right? It's using the tag pointer stuff, but where it's getting, we're
not taking maximum advantage of it.
Yeah,
because we're not actually allocating something in the heap, but we're allocating something in the like accounting for the heap.
Correct. And then another thing that you pointed out in the green room is that another thing that's going to make this expensive is that the accounting part, the vector of the local, so that the handle scope has a vector of all the handles in it. And because we share a single handle scope for the entire interpreter currently, we're just ending, and we never
never free it, so we don't never free anything.
We just have a massive vector that we have to, copy to new memory regions or whatever every time we add to.
Yeah, I mean, I think these are things that clearly we're going to need to fix, but I kind of like the idea of following the benchmark to point us to the order in which we should fix these things.
Mm-hmm.
And it seems like this is pointing us to having an out parameter that's a heap handle as opposed to returning a local handle.
Yeah, I wonder if there's anything else we should. Maybe we should look at the profile before we dive into that. Maybe we should look at the profile.
Yeah, because that's going to be a significant change to the code. That's probably going to take us maybe even the whole episode.
Oh, more than that would take me a couple nights, I think. Maybe we could do it in an episode, but it would be a significant change. Let me see if we can find something a little more episode nuggety. Okay, so
what is the get pointer?
Yeah, why are we spending time under get pointer? That doesn't make any sense. It's just probably just not inlined.
What is get pointer?
Heap scope get pointer?
Oh, it borrows. Oh, I see. It borrows. I'm just looking in the lower left corner here. It like walks over to the heap and looks up the pointer in the heaps array. So it is doing some work.
And is it that it's doing a giant walk? Hold on. Where do we lost it here? Heap inner borrow, scopes. So it could be suffering from memory locality too.
Yeah, it's chasing a couple pointers, but I don't know how expensive that borrow operation is.
Heap inner borrow. I wouldn't expect it to be, although it is theoretically where all the time is spent. I wonder if this would just disappear when the vector got smaller.
That's also very possible. Can we look at the RE heap allocate, the second symbol?
Look at how much time is spent under class for value, by the way.
Yeah, class for value is another thing that we did in a very inefficient way. So,
well, I made it slightly fancier, but no, I actually didn't. Never mind. You were saying, go ahead.
Yeah, because we have the garbage collector and the virtual machine split into two different crates, there wasn't an easy way to walk back from a handle to the class. But I mean, we can make that.
Yeah. Oh, I see. I will show you. Yeah, here, I can show the source through here. This works. Great. Well, for some reason, great. But here you can see, like our previous fancy thing had like a match and probably used a jump table or something like that. And this is just
it's like the string check that takes all the time. It's interesting. Oh, probably because it's dealing with strings a lot. That makes sense.
Yeah, that is the one. But still, it's...
I'm just curious to look at the malloc and look backwards from that to see where...
I'm sure this is vector copies. Yep. 100% in growing the vector. I don't actually know how to get back. Let's do it. Yeah. Yeah. That makes total sense to me that we're spending 17% of total time just growing the darn vector for... I wish I would...
For these local handles.
What's our call stack? Class for value. These are example call stacks, right? Heap scope add. Yep. We just keep making the heap scope bigger, and thus we spend a whole bunch of time growing the vector. That makes total sense to me. So, okay, so listening through things that we need to fix. One is out params here, so we can stop making needless heap scopes. Another is we need to either make it, we need to make it possible to have like smaller heap scopes. Because right now, the way that things are written, we just have a single heap scope that we pass through the entire world, which is not correct.
Which will also allow us to actually collect some memory because we won't be keeping references to everything all the time.
Yeah, I see. And so we probably, even if we add the collection now, we wouldn't actually ever collect anything. Because anything would ever just be still sitting in one of these local scopes.
I think we have to do the heap out parameter in order to then see what the next thing is on the profile because it's so dominant on all of these.
All right, so this is again just all the local. Just sort of thinking through. Here again, class for value.
So why is this so common?
So class for value, I actually think this no longer. Go ahead, sorry.
Can you go up one level? Like, why are we calling class for value?
Oh, it's method dispatch. That's just how method dispatch works.
Oh, I see.
Right, you have to look up the value of or the class of this in order to look up the method to go dispatch to.
I mean, that's the thing we should do. We should make that really fast because that's clearly showing up in a lot of these profiles. I wasn't sort of expecting it, but that's fine. Like, we should be able to make class for value. What's that?
It's class for value is definitely in the critical path. As it said, 36% of time is spent underneath it.
Okay, let's try to make it go fast.
There's also this, right? Try as ref doesn't exist on heap handles, so we use a local handle. This is just dumb. Like, there's no reason why we need to throw this into a local handle. We're just making extra local handles.
Okay. Well, so we try to fix that fix me and see how it affects the profile?
I think I fixed this fix me after I wrote it. So
I also think we could add just a slot on the object to go get its class.
Sure. What do you mean on the object? Do you mean on the VM side?
So after you take the object and you convert it to a reference to the underlying host object, in traceable, we could just have a method on traceable that's like, hey, give me your class. And it could return like a heap handle to the class or something.
Just like a anonymous heap handle, and you have to figure out what it is, kind of thing.
Yeah. Okay. So you'd have to downcast it. But that would be better than this giant if cascade.
Yep. Agreed. Okay. Let's just, before we go, so call method, this is again, this is probably all this class for value time and stuff. Like class for value, I suspect we could just make some obvious wins there. Handle scope as ref, 13% of time. Does that make sense?
Yeah, I mean, it's in class for value. Like all these call stacks are going through class for value.
Oh, I see. It's this. Whoa.
Which I think is not at all needed based on your comment here.
What do you mean? Well, like we need it in order to grab up these. Oh, but we don't need to do it here. Like this should be each, like we're not even hitting this case where we care about this core.
Right.
All right, let's go back to the other code machine, to the real code machine, and let's go start fixing these obvious things. And this is why we profile.
I mean, if this is really important, we could actually put it in the object header. Like it would be totally reasonable for the object header to have a pointer to the class.
Yeah.
And then you wouldn't need to do anything. You could just read out of the object header.
I think it is really important. All right, so this is not our most... I think I'm just trying to get like a before number. I think I can set it to a specific one.
Is that put the output in a file somewhere?
The benchmark to run. Yeah, okay. I just need to name it correctly. String equals. Having a benchmark, this is going to run slightly longer than we need.
Oh, I think this is like a legit benchmark framework that's going to give you statistically accurate information.
Yes, more or less. I mean, this is
theory, supposedly.
This is whatever Bob wrote 10 years ago when he was writing this, or maybe somebody's changed it a bunch since. It's going to be down here. It draws just a few dots. I just wanted like a real number that we could go from, because I suspect we're going to take this from being 3 seconds, which is what I think it is, and we're going to make it 2 seconds. Yeah, so it says that it's 3.05 seconds, right?
Okay.
We could have used the baseline functionality. Okay, so now if we go and look at class, that's for value. This thing. So there's some obvious things. Like for one, I think if we just rename this to be value and remove this, I think it compiles. Yep. Turns out I fixed that fix me after I wrote it.
Sorry, can you walk me through what you just did?
So previously, I was passing this in as a heap handle. I was converting it to a local.
Oh, okay.
So every time you ever tried to dispatch a method, we were going to create a new local for the class.
Okay.
Just to work around the fact that try as ref wasn't exposed on heap handle. It just wasn't exposed correctly.
Okay. But now we don't need to do that.
But we don't need to do that. I mean, there's an argument of, is it safe to be holding on to this heap handle throughout here?
Okay. So can we try running the benchmark to see just that change, how that affects things?
Sure. I mean, that should make it faster. I don't know how much faster. Where's my... I never understand like where it buries the terminal. I get to it by clicking this warnings thing, but that can't be the right way to get to your terminal.
What if you have no warnings if your project is perfect?
Cargo, build, release. Oh, this is Windows, darn it. I don't like it. Too many years of working on Linux. I remember when I started at Google, they let you choose what kind of desktop you're going to have. And I had come from Apple. That was my previous company. Well, before my startup anyways. And so I chose all the Mac stuff. And then I arrived my first day and my manager was like, nope, we're replacing this all with Windows stuff. Because I was on the Chrome team, only Windows.
You are working on a Windows application. You cannot use Mac.
Why is it linking? What? Did I create a problem that I didn't realize?
It says all warnings. It doesn't see there's any errors. Oh, function is not used.
What? Insufficient data? What?
Disk space. Your disk is full.
Oh, you know what? Welcome to Windows. I had the profile open, so I bet I can't write a new.
Oh.
So how is it 2021 and that's still a problem in Windows?
Oh, it's just a design of the Windows kernel that files are locked when they're opened. Do you think you can pass a flag when you open a file in Windows to say don't lock the file? But the default is, and all software essentially locks the files.
But that seems like a total foot gun, like from the user's perspective.
Depends. Like if you're thinking of a desktop use case where like you've got your document open and you're like typing a letter to your grandma or whatever, and some other program tries to come around and mess with the file, you'd rather it not. I don't know. It's just a design thing. Like it's sort of weird on Linux that you can like rm-rf/. It'll just go delete your entire file system out from under your running system. And, many Linux programs will just continue to run just fine with like no file system behind them anymore. It's amazing.
So what we just saw in between our Windows discussion was that we're now, what is going on? Oh, does this like not, this is not the fanciest.
Argument parser.
Oh yeah, and so it's when I do generate baseline, it's trying to run all of them. Anyways, we saw that it was 2.9 instead of 3.0. So I think when we remove this core classes lookup from the critical path, which as you said, we probably could even do better than.
So I wonder if we should also, as a next step, instead of returning a local handle here, what if we had an out parameter that was a heap handle? That would have saved all these from heaps.
Sure, for this specific class, because there's no reason why.
Yeah.
All right, so here we are. We're slightly better. Yes. Okay. So I'm sorry. So again, I think if I rewrite this, because we have fancier technology than when I wrote this. So if I just do let core equals scope dot from maybe heap.
And do why do you need to get what is core of itself?
Core is.
Oh, I see. This holds the core classes.
Global handle. So this is this isn't.
Yeah, in principle, you wouldn't have to do this. It's sort of, well, okay, fine.
What I was just going down was not actually going to help. So this is an option global handle, which we have to get a reference to. And we really should do this inside here to avoid doing this for all the Oh, interesting. Even string needs it.
Yeah, I don't think it's going to save our particular case.
Well, I thought it would. Okay. But this is unfortunate, though. But go ahead.
Mm-hmm.
Because this is just a whole bunch of lookups. And I think, does this also make it a local handle?
Yeah.
Yeah. It doesn't need to, though, actually. Well, I guess it does for lifetime. Because otherwise, how long would this live?
Who is the caller of this? Like, I wonder if the caller of this could hand in the core classes instead of you having to go find them every time.
I think there's a couple callers, but the hot caller, which we could, is not that. The hot caller that we can, of course, change, because we control the whole thing, is this one. Call.
Right. But if you roll, scroll up here, this is a big loop.
Mm-hmm.
Like, it would be entirely sensible to hold on to the core objects while running this loop.
It is true. The core objects, what is this on? This is on VM. So would we then just have a long-term borrow in VM? Which might be fine, because I think we have VM immutably borrowed. No, we've mutt borrowed self.
I just meant at the top of this loop, like in this function as a local variable. You're looping over all the instructions and dispatching them. While you're doing that, you could grab the core classes once and then just have them.
Okay. I mean, that would, yeah, you'd want to do it before the loop.
Yeah, the same way you borrow like the closure and the function object.
Yep. That's reasonable.
I'm sort of thinking of this as an experiment. Like, we could try to hack this up a little bit to see how it affects the benchmark. And then based on what moves the benchmark, we can decide what the prettiest way of doing each optimization is.
Yeah. I mean, that doesn't feel like an optimization that could ever, well, maybe it could land, but wouldn't be great to land as is. Like, the better way of doing that, I think, is what you suggested earlier, where, oh, but that doesn't actually.
Well, essentially, instead of, like, right now you have this function class for value on the VM, but what if you moved it onto the core classes object? So the self that you had with you was the core classes object.
Mm-hmm. Yeah.
For now, I would just make a copy of it over there to try experimenting. Because you don't really, the only thing you use from self here is to go access the core classes object.
Yep. Fine, let's try that. That, I think, is that is an excellent way to approach this. Or an excellent way to reason about it, in that it could just go on this object.
Yeah, I guess you could refactor the original one to call through to this one.
Sure, but we don't even need to. We can just start here for now. So here we just don't
do that.
Like, you just have literally self.
Mm-hmm. This is an example of how I.
But like, you also want to just return a heap handle.
Sure, make it return a heap handle. Go for it. Well, heap handle doesn't have an A. You're gonna have to make it an out parameter, which is gonna be a little trickier. Let's do it in separate steps.
Yeah. Okay.
There's always this question in object-oriented programming, like, where does your method go? Because in principle, it could go really anywhere in a big object graph.
Mm-hmm. Okay. All right, so now this is never called. As you said, we trivially could just...
Yeah, make this one call through, just so we don't duplicate the code too much.
Scope value. Okay, and now let's try this one. So you think that we should hold on to this early, or up here, before we get into the loop?
Yep.
And then the core.
Okay. See if that moves the benchmark.
I would expect it to. But that's what the benchmarks are for. I have fond memories of doing lots of benchmarking of browser code and building small programs.
It's fun. It feels like a game. Like you have this mental model of how the system works, and then you look at this profile, and then you like turn the program inside out and see how you can move the benchmark. And often you can move the benchmark a lot by doing this kind of stuff.
Something's wrong. Like it was like this, at least it was taking a super long time.
It's mad.
Oh, you mean like it's mad like in a... All right, let's try this. Cargo run. Renc test benchmark string equals. So like it's going super slow for some reason in that, suggesting that maybe I have some runaway process on my machine or something. Option unwrap.
Maybe these aren't initialized originally somehow.
That doesn't make any sense. Self core. Oh, yeah, it totally could make sense.
Why don't you keep it as an option and do the unwrap when you're actually going to use it?
Well, that's before our asref.
Oh, I see.
It also wouldn't, even if you kept it as an option, it wouldn't change whether it was there or not, right? But hold on, let's see. This would be executing something before core was initialized. Like, I'm not sure that actually does make sense. No, it does make sense. But then how? Oh, I see. You can't do any method. I don't know. Maybe we should just see. Like, we can just see this in the debugger. Or we can do this in equals ren debug. Does this make sense? I'm gonna like get deep in the debugging weeds here if I'm not careful. Everything? Okay, everything is barfing.
Yeah, imagine just during the like initialization phase somehow
doesn't have core set, which is true. The initialization phase doesn't have core set. Just try that and see. Fire up the debugger. I have no idea why this opened a thing there. Okay, we're panicking. Load ren core.
This populates those values somehow?
I'm sure it does, because I think if we look in VM new, like set the core module. But like I would have thought that the base classes were already initialized. But I guess not. We do ren core, ren this thing. Wrong one. Wow, we're like paging this all back into my brain here. Yeah, so ren core sets all these things. But we could also just not crash.
Yeah, why don't we try not? I view this as an experiment to see how much it affects the benchmark. So I'm willing to write sort of code that will need to be cleaned up before it's landed in order to see what the experiment does.
We could do something like that's right. So find it where it was. Okay, so this.
You can just wrap it in like a caching closure or something.
A caching closure?
I don't know what the like Rust idiom for that is, but
I was just thinking I could make this an option, basically. Right, so I just do this map. Make this a handle that gets so now we have this like option core classes. We do core dot class. So this is then either.
I'm gonna put a mud in front of your core, right? Go ahead.
Anyway, so this then is either well, it just doesn't. This is just core dot unwrap.
Yep.
It's never valid to like call stuff when you didn't have core at the start.
Okay.
Okay, let's just try it. Are we like still in the debugger? Oh, that's why it's orange down here. I never fully understood the design aesthetic choices. It's still being super slow for reasons I don't get, but no, it didn't crash. And the super slowness makes me doubt that we'll get good benchmark numbers.
You think you have like a runaway process running on your
machine? Yeah. Well, that would, yeah. I can control alt delete here in a second and check. I have no idea what that'll do to the stream.
I always trust like benchmarks run by servers. I don't ever want to run that benchmark actually locally on my computer.
Yes, sorta.
For experimentation, it's really good, but for like the official, like, what did I really do?
I've been working on this project at work, or been working with my team on this project at work, and like one of the core problems we've had to solve is how to make the things we profile on our desks be the same as the things that get profiled on the server, be the same as the things that the users experience. So here we go.
That made a big change.
Big change.
So we add that to our file so we can keep tracking what we're doing.
Oh, what was this one? This was removing value local handle. This was moving to cached core. Okay. Not bad.
Should we run the profiler again, or do you want to keep banging on?
Well, I think
value.
We certainly can run the profiler again. It's built the thing, so let me launch sleepy, whatever this thing is called. Very sleepy CS.
Sleepy is like the opposite of what I want. It's like this naming trend where you name the thing for what you don't want. It's like naming blink because you don't want a blink tag, or naming the pixel book pixels because you don't want to see any pixels.
Okay, so let me do my screen shuffle. Screen shuffles will continue until morale improves. All right. Okay, 97% of time in that, which makes sense. 30% of time here.
Oh, heap allocate dropped down. It's now not the number 2 symbol, it's the number 4 symbol. That's interesting.
Because we're creating substantially fewer local.
Yeah, I think we're thrashing the allocator much less.
Yeah, I expect this to disappear because it's not like they haven't optimized this. It's just that we're
just calling it too much.
Well, and constantly asking us to do large amounts of memory. All right, so what do we got? This thing. Oh, I see. This is in the.
Can you expand out the name so we can see more of what these functions are?
Handlescope add.
Oh, okay, that's interesting. Oh, now we're actually in the object EQ. We're no longer in class for. Oh, we are a little bit here.
Oh, these are just.
They're samples, I know, but like before, everything was in class for value. Now it's, I guess it's in class for value. Oh, class for value calls create bool. No, these are different.
No, this is averages. We have to look and see what the create bool. That's from object equal, which makes sense, right? Because we're again thrashing the right. We're thrashing our poor vector every time to just hand back this bool.
Right. So this I think we should do with the out parameter.
Well, maybe we could practice our out parameter by making it possible.
With the, why don't we try it in heap for value to see how it would work? Because that is called in a bespoke way, as opposed to this one is called through like a whole, hundreds and hundreds of functions are called with the same template.
So well, that's why it took us weeks to like convert the core VM, and then it only took me some number of days, but like I had to work up to do the core.rs file, which again is like all the various primitive implementations. Primitives they're called, like num add, that kind of thing. It's like converting all of these will be substantial work. We could add like an optional parameter that only some of them use, or yada yada yada. But there are ways that we could work around that. But we don't have a lot of time left in the show.
Well, I think we should try it for class for value because it has the same structure, just to sort of show how it would do with that, and then we can scale it up to all the other functions in the easy bake oven between episodes.
What I am realizing is just how expensive local handles are.
Yeah, I mean, it's you have to allocate a slot for them. Like this is sort of the reason why tag pointers are such an important optimization for virtual machines, is because it allows you to deal with these very basic types that are the leaves of all your computations without. It's like we're not even creating an object for it, right? Like imagine if you were creating an object to back it. All we're doing is creating the handle for it, and it still shows up as the top thing on the profile. And so skipping that step is even.
Well, again, it's the scope add, right, where we add ourselves. It's this push. Yeah, it wasn't showing up, but like all the time spent in this push, which makes total sense. Right, we're going to allocate a cell for it, which means space on the vector.
So there's other designs for this. So other VMs, the handle scope just has a fixed size. It's just like you got 1024.
Yep.
And it's your job not to overflow that, and so they don't do this incremental pushing. But I think it's we're not at that phase yet. Like the things that are calling push are things that shouldn't even be allocating handles.
Well, yeah, but we also should have more than one of these, right? Another problem here is that we have a single handle scope.
That's true. So easy thing we could do is we could create a handle scope for each call into this loop.
I don't know that we actually have that technology. I used to have multiple handle scopes, and then I lost that. But we could look at that, just seeing if there's anything else obvious here.
I definitely think we're going to do that, but I don't think the profile is pointing us to that just yet. I don't see any.
Well, this is pointing us there, right?
Except the callers that we're seeing for this that are showing up on the profile are all callers that shouldn't exist. And so I watched this great interview with Elon Musk at his like Starship shipyard or something in Texas.
Yeah.
And he was talking about the what is the process for engineering a system? And I think the first thing was question the requirements. So I think we're past that step. Like we know that we want a virtual machine in a GC because that's sort of the premise.
Sure.
Then the next thing was delete the part or function. And so that's the step we are now. Like the things that we're seeing in our design that are expensive, we should just delete because they shouldn't exist. And it is only the like fifth step that is optimize, which is like make fast. So we shouldn't try to make fast a thing that really we ought to delete.
Okay. All right, let's go back to the actual code machine. I think this is. Oh, I see. That's what this is. That's what that was prompting me for. All right, we don't need that. All right, so we were talking about making this possibly return a heap handle.
Right. Really, I think we should do this for everything, but I think for the purposes of the show, it's tractable to do this one function.
And it's this caller where we want.
So what does it do with the result? What does it do with this class?
We take this class and we just grab the obj class out of it.
So maybe we should just return the obj class. Like, why are we returning a handle at all?
That would be fine. What's the lifetime of that obj class?
We're going to say it can't go away. Like there's a value we're passing in. We're going to say that thing is going to have to live as long as that value.
I see. So we're going to pass in a.
Let's go look at the signature of the function. I think it may be obvious with the signature of the function.
Okay.
Let's look at the signature of the class for value function. Yeah. Oh, it's a heap handle. That's unfortunate. Oh, okay. But
we could just. What about if we passed in? Can't you just pass in a slot basically? Like maybe I'm not making any sense. Like what if this class was an obj class ref? I guess we can't make that. We can't start that as null. An option obj class ref and then pass in the option to get it filled. Like I'm saying, a thing you could like have this caller own the lifetime of the object, as opposed to returning a lifetime out of this.
I think the easiest way to do that is in fiber.stack.
Okay.
You see where stack is described on fiber, we should have a slot on fiber for the current class that we should populate and clear in this method.
That makes it live way longer than this method.
Oh, that's fine, but it just makes it traceable. Like the important thing is when you're dealing with heap handles that you have some way of tracing them so that the objects that underlie them don't disappear.
I see. So we would pass in that as the slot. Yeah, we were trying to use that trick before as well for the
we had like a pending result.
Yep. And so this is the like current class. This is current class for call. Should it be an option?
Oh, we're gonna have the same problem we had with the stack, with the pending result for the stack, which is we're gonna need a mutable version of it.
Oh, mutable version of fiber, which we don't have right here. We could potentially re-architect things, but in the previous Rust ref cell based implementation, we did not have a mutable fiber here.
What if we had a local handle that was immutable, and you would pass in the local handle,
and fill
it in?
Would that be for the length of? So you just end up with one?
So you just keep it on the stack, like that's.
No, I meant that like, well, you could just have it as you just have like one up here, right?
Yeah, exactly.
on this stack. So you just have let local. But this is class dispatch. Something like that. Self dot. We want this to be an obj class.
I would just say like scope dot create null.
Well, that's going to make it a.
Okay, so you can say scope dot from heap. Oh wait, this problem that the core doesn't exist. I was going to put the null class in there or something.
I mean, we could have an object that held both of these things, right? And was an option. We basically have two. We have a state machine of like whether you're running before core has been initialized or after.
Mm-hmm. Why don't we just try, for simplicity, just creating it on the stack right here? It's not going to move the benchmark, but just to sort of get a feel for the structure, and then we can try moving it around later.
We like from heap from the null or something?
Yeah.
I mean, we can make an untyped one. We can make an untyped one easily.
But then we'll have to downcast it.
Yeah, we just downcast it, which is doable. Like trivially, we can make an untyped one, right? So we do let for dispatch or whatever the heck this is called. Dispatch is equal to scope dot create untyped handle.
Okay.
And so we now could. And does this need to be made mutt here?
Probably, yeah, mutt. So the purpose of this is now this thing is attached to the tracing machinery. So if we try to collect, we'll see whatever we put in here.
We're going to end up in this one as well eventually, but call, sure. So now this stops returning anything. And then takes in at mutt for dispatch. Except you really want the heap handle version of it?
That's fine. No, you want the local handle, it's fine.
Okay, so let's look at this. And this is going to be the out is at mutt local handle. That's kind of nasty, but sure. Okay. And then how are you going to set its heap handle?
I would just say out.set from heap. And then I would try to implement that function.
Okay. I'm going to keep making faces. This also should probably return a result at some point. But we'll fix that another time. All right, so this is a bit wild, but sure, why not?
This doesn't seem right. I think we're going down the wrong path here. I think we should return an out, which is a mutt heap handle, because we're going to have to do that for the actual call itself. So we're going to have a place like a pending results. Anyway.
Oh, like a generic one? Or like each place gets a different one to stomp on?
I think we're going to have in our stack object. I think we should factor out the stack object from the fiber, and on it should have the list, the pending result, and this for the class for dispatch.
Okay.
Because I think that's the structure we're going to need for the method dispatches.
Okay. Let's see. What do we got? wait for time. Yeah, we're basically at time. We may need to talk about pizza and come back to this next week, or really I'll have gotten it done by then. But just to go over, well, it's in my head. So yeah, trivially, I'm replacing this stack.
Why don't we just write the data structure? We don't have to do anything with it. Just the data structure I was imagining. Oh yeah, you can do it.
Is values is list, right? Ending alt or something like that, you said?
Yep.
And this is class for dispatch.
All right, and this is now option heap handle class object. And then the point of doing it this way is just that now when you're tracing obj fiber, you can call trace on stack, and stack can trace all of these things.
That's trivial.
And then, right. And so
this fixes our mutability.
Because stack would be mutable because we have to. The point of the fiber dispatching is to mutate the stack.
Yep.
It fixes our traceability because it's traceable. And then totally gets rid of all this need to have these local handles being created and allocated because we have sort of pre-made slots to put them in for tracing.
Okay. It feels doable.
It's sort of interesting. The structure points you to. I was listening to there was some sort of like Twitter Spaces conversation about this operating system called Oxide. I guess it's some operating system written in Rust that's for like deeply embedded devices that want really like high assurance, like correctness guarantees. And one of the features of it was it doesn't have dynamic task creation. Like when you compile the system, you have to say, these are all the tasks that can exist in my system. And that sort of makes sure that you have enough resources provisioned that your system is going to be able to run correctly. And this sort of has the feel of that. Like we're sort of like structurally making space for each of the like intermediate values that we're going to want to have. Instead of the handle scope and the local values are sort of allowing us to dynamically create and eventually destroy the slots for these things. And then we're gaining efficiency out of it because the structure is exactly the way it is. We don't need to spend any amount of time allocating and deallocating and managing these dynamic slots. And so I think that the system that they were talking about was clearly for its purpose makes sense, but it's hard to make a general purpose system out of it because a general purpose system is usually overcommitted. Like if you had to pre-reserve space for everything you could possibly do, you would not have enough space for all of it. And so you use this dynamic patterns to basically deal with the overcommitment that you're making at the cost of paying for management. But for these systems like a virtual machine where you have these really, really hot code paths, it makes sense to sort of statically lay out the structure so that you can then execute those 6 lines of code that you're running all the time as efficiently as possible.
Yeah. It is wild how it's always these 6 lines of code that you tune down.
Well, people design their whole languages around these. This is method dispatch, right? And so you design your whole language around like, how is my method dispatch going to work and how much flexibility do I have there? Like in C++, it's just like you have exactly a table that you can index into and indirect jump. Like that's it. Like you don't get string lookups like you do in Objective-C or something.
Oh, I realized we didn't say this at the top of the episode, but so I don't think I compared these profiles to SafeRen or RenC. But we are currently on this benchmark, the string equals benchmark, about 5 times slower than SafeRen. And in total, about 15 times slower than RenC.
I'm hoping that if we do this, we should be faster than SafeRen and hopefully getting closer to RenC. Because like everything we're seeing on the profile is like GC related, but should be just removable, right?
Yep. Again, the hope behind writing this GC was that we could end up as fast, maybe not faster, but as fast as RenC. Well, this was fun as always. I now have a whole bunch of to-dos, hopefully to done this weekend when I get to them. But yeah. Otherwise,
it's exciting to see it run. Like,
oh yeah, it's been quite a journey. Otherwise, I think I don't have my calendar in front of me at the moment, but I think we're again maybe Tuesday next week. Because next week, are we? holidays again? We'll see. We'll announce on Twitter. Looks like next week, 23rd.
Yeah, we'll tentatively say Tuesday, but check on Twitter if you want the exact information.
Yep. So, anyways, great to chat with you, Adam.
Yeah, see you next week.